Hello, everybody. Hi, Angie. I'm Laurie. I'm VP of Developer Relations at LlamaIndex. In a former life, I was co-founder of NPM Inc., so, ask me about software registries, I know a little bit. But these days, instead of talking about JavaScript, I'm talking about AI. What are we talking about today? We're going to be looking at the available agent-to-agent communication protocols. When I proposed this talk, the title had 3 protocols in it because those were the only 3 that I'd heard about. In the course of researching this talk, I discovered 11 additional protocols. So we are going to have to go very quickly indeed, because I have only 15 minutes to talk about this. And that's going to be tricky because there's detail and nuance, and I don't have time for it. So this talk's going to be spicy. But first, a disclaimer. Who the fuck am I to have this conversation and have this talk with you? I learned about most of these protocols in the last 4 weeks. Hardworking engineers have sunk hundreds or thousands of hours into making these protocols work. And I barely scratched the surface of most of them, so any omissions or misrepresentations of what these protocols do or how powerful they are entirely my fault. On the other hand, I don't have a horse in this race. I'm not a contributor to MCP yet. I am not a contributor to any of these other protocols. I am a relatively impartial observer. This is not going to be an opinion-free talk, though. In fact, there are going to be plenty of opinions. Before I get started, I wouldn't be doing my job if I didn't plug LlamaIndex just quickly. We do our best to work with all of these protocols, and we have one-liners that will make either a server or a client for you in the framework for an MCP server. I encourage you to give it a try, but that is the end of the plug, and I would like to make clear that the opinions I'm expressing are not those of my employer. An incredibly valuable resource for me when I was putting this talk together is this paper by Yang et al. From April 23rd. That was a whole month ago, so it's completely out of date now. But it's incredibly useful. It is a great in-depth look at all of these protocols, and it's well worth your time to read. This is the list of protocols that we are going to look at. I promise you that these are all real protocols except WTF and LOL, which I just put in there for no reason. Although there are probably protocols called that at this point, because nearly everybody is working on protocols right now, it turns out. And nearly everybody working on these protocols is aiming at the same thing. Agents can do amazing things, so agents should be able to do even more amazing things if agents can work together. The one exception to this rule is MCP itself, which does not necessarily have agent-to-agent communication as one of its design goals. In fact, there's quite a lot of controversy about whether or not they should do that, although various people have made good cases for that happening today, I think. But all of the others are mostly on the same page. Agents should be able to discover other agents that exist. Wherever they are on the internet, they should be able to authenticate to them, communicate with them, form coalitions to solve problems, negotiate with each other and debate, and generally create a brave new world like Jarvis of autonomous software that will accidentally lead to AGI. What is the reality right now? The reality is that there are 13 different protocols, and none of them are completely solving the problem. Most of them are half-baked at best, is the fact of the matter. They vary wildly in scope and completeness, and the closest thing to a standard so far is MCP itself. And MCP is not very close to that vision of inter-agent communication on the internet. In fact, it might not even care about that vision. Does it want to do that? Let's talk about that. This incredibly helpful taxonomy diagram is from that same paper that I just mentioned. It splits protocols into 2 categories. One is context-oriented, and one is inter-agent. And then within each of them, it has some subcategories. What do those 2 categories mean? Context-oriented means the goal of the protocol is to provide an LLM with context to achieve its goals, so basically tool use. Within this category, MCP stands almost alone, along with agents.json, which I'm going to talk about in a bit. The idea is that the LLM makes a request, it gets a response, it's kind of synchronous, it's kind of fast. Inter-agent means that the goal is for agents to communicate with each other. They go beyond a request and response. They should be able to discuss, they should be able to negotiate and debate, and then come to some agreement that solves the problem. It is a grand goal that very few of them achieve right now. Most of them are still at the request-response stage. Which brings up a really important question that several people have already asked today, which is what is the difference exactly between calling a tool and invoking an agent? We're going to ponder that later, but for now, with this taxonomy in mind, let's do an extremely lightning-fast tour of all of those protocols. First up, MCP. I'm going to spend no time at all explaining what MCP is. Everybody in the room knows what MCP is. Next is agents.json. This is the only other protocol in the context category. It's a file that sits at an easily discovered location on your domain, and it describes what your APIs do to an agent. It describes not just, it's based on OpenAPI, but it doesn't just say, here are my API calls. It says, here are what they do, here's how you use them with each other, here's how you chain them together to achieve a goal. Then there's A2A. If you've heard of any other interagent protocol, you've heard of A2A. Google has made an enormous amount of noise about it. It is built on a lot of existing protocols, and one of its key differences from MCP is that it's expecting to call agents. So it's expecting those calls that it makes to take a long time. So it has a bunch of async stuff built in that MCP has not yet focused on. It makes a call, it gets a status. So being async is a strength if the agent on the other side is going to take a couple of days to respond, which is something we saw earlier. I had a call with the developers of A2A on how it's different from MCP. Their perspective is that agent-to-agent communication comes with a very different set of problems in the long term. The problem is there's not a lot of difference between A2A and MCP right now. In the long term, they're going to diverge, and the MCP isn't going to care about inter-agent communication, is A2A's perspective. And A2A is going to take care of those problems for us instead. Do you buy that vision? Do I buy that vision? Let's talk about it. ANP has a lot in common with what we've already seen. It lets you discover a list of agents from a well-known URL in the same way that agents.json does. It uses a standard called DID from the W3C to help you do that, which is distributed identity. And this is where it gets into trouble really quickly because DID is a blockchain thing, which means that this protocol is extremely blockchainy, and there's a non-trivial chance that they're going to launch a coin, which is enough to make me stay the hell away from it. AITP is another blockchain thing. It is very concerned with how much an interaction costs, and it allows competing agents to bid to solve a problem. So don't get me wrong, figuring out how much your agent interaction should cost is a real problem that we're going to have to solve eventually because agents are expensive and we can't just run them for free forever for software to interact with each other. I don't think it's the first problem we should be solving. And blockchain has not solved any problems so far, so I don't think it's going to solve this one. Next up, there are two protocols called ACP. Great work, everybody, on naming things. The first one stands for connect, and the second one stands for communication. The C is different. First up is AConnectP from our friends at Cisco who are sponsoring this talk, so I'm really on dicey ground. It has a very nice ABI and an SDK. LlamaIndex is integrated with it. It is a lot more baked than some of these, but it doesn't have a whole lot of differentiation from A2A, if I'm being honest. It defines how to find, describe, run, and retrieve responses from agents. One thing that's different is it also describes how you host and launch an agent. So that is a baked-in part of the protocol, is download an agent and execute it on your local machine, and that is part of the protocol. Which is an interesting distribution mechanism to have as a first-class citizen of your protocol. I was also able to talk with the developers of AConnectP. Like A2A, it can use MCP under the hood, but like A2A, it doesn't have a great story for what happens if MCP figures out the tools are just agents. One thing it does have is a registry, a distributed database of all agents worldwide that you can search to discover agents who can perform the task you need. As we heard this morning, MCP is working on a registry. ACOMP, Communication P, is from IBM, who have launched a whole little sub-brand to seem cool. It's called BAI. It's got a blue sky account and everything, so you know that it's grassroots. But it's doing very much the same set of things as A2A, and it is in fact a fork of MCP. So they are diverging rapidly. They have already forked. They are diverging rapidly from what MCP does, but they are diverging towards what A2A does. So again, they have a differentiation problem. Then there's Agora. Agora is genuinely fascinating. The thing that Agora does that nobody else is doing is it starts as a completely natural language protocol. That is the only thing the protocol specifies is you start with natural language requests, and then either participant in the agent-to-agent communication is allowed to respond with a protocol document, a natural language description of how to upgrade the protocol to a more formal protocol to complete the task that they are participating in. That is an incredibly interesting LLM-first idea. It is a protocol that upgrades itself and makes itself more efficient towards the task that it is being requested to do. I think that is something that everyone should take a very hard look at. But it is mostly at the idea stage. Then there's a bunch of 4 domain-specific protocols that are definitely inter-agent protocols, but not general and purpose enough to really compete with MCP. I'm not even going to cover them because I have no time at all left. So there's human-agent interaction protocols. There's robot communication protocols. They're for agents to talk to robots. Then we get to Elmos. Elmos is a fascinating effort, not least because it's from the Eclipse Foundation. If you're not familiar, the Eclipse Foundation is IBM in disguise. So this is another branch of IBM building exactly the same thing that IBM is building. And if you think that's unusual, you have not spent any time interacting with IBM. And finally, there's Agent Protocol, which I like primarily because of the name. It's just Agent Protocol. There's no other Agent Protocol. We're not admitting to the existence of other protocols. We are it. But again, very little daylight between it and what the other ones are doing. So that was our lightning tour of the universe of inter-agent protocols, which I'm going to collectively call the A-star protocols because they nearly all start with A. And MCP, which isn't an inter-agent protocol yet. MCP wants models to get context for things, and the A-star protocols collectively want agents to be able to get agents from get data from other agents. Is there, in fact, a difference between those two things other than how long it takes? A2A says there is because one might take a long time and there might be a multi-turn negotiation, that there's authorization and payment to think about, all of which is true, but A2A doesn't have those yet either. A2A is just saying that we should have them eventually. So what does MCP lack that the A-star protocols have? Well, almost nothing. If you know where an MCP server is, you can discover its tools and resources. That is how discovery works for nearly all of the other protocols, except AConnectP. It has authentication and authorization. It arguably lacks a good async story right now, but as we've been told today, that's going to be addressed soon. The ability that Agora has to renegotiate and upgrade its protocol, it doesn't have that, and that is a really interesting idea. What MCP has that none of these others have is adoption. By tackling a small, constrained problem to start with, MCP has demonstrated clear utility as evidenced by how much adoption it has in this room, in this conference, in the world. Kent made the point to me that it's kind of like React in that React solved this very small problem and conquered the web world, and MCP has done the same thing. It has conquered a small initial problem, got traction, and now it is able to take that traction and expand to the larger universe of the problem set that it needs to solve. When it comes to forming a de facto standard, it has the attention of the public, and attention, as we know, is all you need. So, what about the other protocols? Can it be combined with them in the way that A2A wants? A2A wants MCP and A2A to live next to each other harmoniously. MCP features in A2A's architecture diagrams as the right solution for tool use, and they could take care of the inter-agent stuff, but I am so far not convinced. MCP is highly duplicative of all of these other protocols that I've talked about. Adding another protocol to the mix seems to add complexity for minimal gain, while adding inter-agent features to MCP seems like a relatively small lift. In fact, we saw a talk earlier in which the presenter showed that you can already do it. So does that mean that MCP is ready? We've got a world of inter-agent communication already rolling and ready to go? Not in my opinion, no. There are a few things that all of these protocols lack, including MCP itself, stuff that nobody has satisfactorily addressed, and I'm going to cover 3 of the big ones right now. The first is a registry, which is under construction, so that's great. That might sound predictable. As a co-founder of NPM, I'm like, oh, you should have a registry and it should be centralized. Of course it should. All of these protocols implement a discovery mechanism But you have to know a server is there before you can ask it for anything. There's no universal way of searching the entire web and saying, hey, I have this task that I need to complete. How do can somebody show me an MCP server that solves that problem for me? So you need, for that, a unified central registry, even if it is a federated registry, as has been discussed. The next big hole in all of these offerings is authorization, which is not the same as authentication. Many of these protocols have at least a sketch for authentication, but imagine a world full of agents with the centralized registry that I was just talking about, advertising themselves as agents advertising themselves as capable of performing certain tasks. How do you get authorization to perform those tasks using that MCP server? The blockchain people are not wrong. You do need some way of negotiating permission to use somebody else's hardware to solve a problem for yourself, and you're probably going to have to figure out a way to pay for it. Like I said, I don't think it's the first problem, but I do think it is something we're going to have to figure out eventually. And closely coupled to those other two is reputation, which is something that the registry guys said that they were explicitly punting on, which I don't think they can do. In a universe of discoverable agents, there are going to be many, many agents doing similar things, doing the same task, presenting themselves as saying that they can do things. And we just had a talk about security where we learned that if a tool advertises itself as one thing, it could be doing something else. It could be a completely abusive tool. You need, in a world of discoverable agents, you need reputation. You need some way of knowing if everybody else is using that agent, and therefore it's probably okay, or if it's this rando agent that nobody has used. That is going to be a critical problem if we are to solve inter-agent communication at a global scale. There are a ton of open questions, and we've been listening to these talks all day, but MCP is doing great work, and my conclusion is that so far, it is all we need. So where do we go from here? I sure as hell don't know. That's what you know, but I'm on board with all of you to find out. Thank you very much.